We are taking an example of Laplace transform of Heaviside step function u t minus 4 times e to the negative 2 times t. And we know the formula for Laplace transform of u t minus c times ft is e to the negative cs, then Laplace transform of the function f t replaced by t plus c. So if you go with this formula, you have seen ft is actually e to the negative 2 times t. So then this one you will write e to the negative 4s and then Laplace transform of e to the negative 2 times t plus 4, right? Because we are replacing ft by e to the negative 2 times t, and then f t plus 4 will be e to the negative 2 times t plus 4. So that one is basically e to the negative 2 times t, and then e to the negative 2 times 4 is 8. So this one then you can combine like as e to the negative 2t and e to the negative 8. So e to the negative 8 is a constant. You can pull it outside. That gives e to the negative 4s minus 8. And then we'll find Laplace transform of e to the negative 2t. And you know that this one is 1 over s plus 2. Because you remember the formula. Laplace transform of e to the at is known as 1 over s minus a. And our a in this case is negative 2. That's why you get this one. And this is the Laplace transform. We are done for this part. We are now taking one piecewise defined function. We want to find the Laplace transform of this. So if you go with the direct method, you have to write 3 different integrals. So we are not doing that one. We want to transfer this piecewise defined function to the Heaviside step function form. So for that purpose, we take the boundaries here. We have a 2, and then we have 3. So the function value between 2 and 3 is 4 sine pi t. Right side of 3 is 0 and left side of 2 is also 0. So then the form of Heaviside function will be very simple here. This one is u2 and this is u3. So we write this one as u2 and then multiplied with 4 sine pi t plus, then I'm taking u3 multiplied by 0 minus. So negative 4 sine pi t. Okay, so that we have found. Now we are taking the Laplace transform of this one now here. So u2 meaning is ut minus 2, so it will be e to the negative 2s. And this one will be now Laplace transform of 4 sine pi. Our t will be replaced by t plus 2, as you know. And then e to the negative 3s. So this one will be now, we have Laplace transform of negative 4. And then I need to take here sine pi and then t plus. Now what happens? If you know basic trigonometry, then you know that sine pi times t plus 2, it is this one with the reference angle concept, pi t plus 2 pi. So that basically just sine pi t. Because if you take 2 rotations here, 1 rotation like 2 pi complete rotation, then plus that goes in the first quadrant, it comes out with sine pi t. So then this one is e to the negative 2s Laplace transform of 4 sine pi t. And then you can take this negative outside if you want. Also 4 you can take outside, e to the negative 3s. I could take this 4 also outside, not a problem. And then when you look at here, this one is 3, right? So now we can see what happens in here. Sine pi t plus 3 pi. So that one will give you negative sine pi t, because your rotation is 3 pi, 1 pi, 2 pi, 3 pi is here, then goes here. And in this case, sine is negative, so you get another negative. So this negative altogether will be positive here. Laplace transform of sine pi t again. Okay, now we remember the basic formulas for Laplace transform of sine at will be a over s square plus a square, right? That's the Laplace transform of sine at. So we'll be applying this one to get our final answer. So we get e to the negative 2s. You can keep your 4, and then sine pi t gives you pi over s square plus pi squared, plus 4 e to the negative 3s, and then sine pi t again gives you pi over s square plus pi squared, and we are done.